Thank you for joining me for this recap of new solutions presented at RAPID TCT 2023. I'm Todd Grimm, president of T.A. Grimm & Associates, a consulting and communications company, and one of the many advisors for this event. RAPID TCT 2023 was a fantastic show by all measures and all accounts. And one of those measures is that the show floor was the largest in the event's history. Now, this was a bit of a good problem to have for me, and I'll explain. But first, I want to clear up that this is not a comprehensive review of all things new at the show. And there's two very good reasons for them. One, to cover it all, I'd have to make this video part of a series because I assume that you don't have the bandwidth or the desire to listen to me drone on for hours in one sitting. The number two item, and more importantly, and related to the good problem to have, is that I did my best to see everything on the show floor, but I failed at that task. I spent more than 15 hours in the exposition, sacrificing all of the great main stage and conference presentations, but that still wasn't enough time to see it all. I guess I should have heeded my own advice, which I mentioned in my pre-event video, and that advice was to make this a team effort because you can't see it all when going solo. So the lesson to be learned is for you to plan to have others on your team join you when you're preparing for RAPID TCT 2024, North America's most important and largest additive manufacturing event. I know I'm not alone in having a mix of feelings, both mental and physical, following the event. I was exhausted, but at the same time recharged and excited. I was better informed, yet still very overwhelmed and still confused in some aspects. RAPID TCT will do that to you. The more you see and hear, the more you learn. But that knowledge leads to a realization that there's still much more to discover, to learn, and to absorb. Additive manufacturing is a journey, not a destination, and I'm glad to have attended RAPID TCT to aid me in my personal quest. While production was the overarching trend on the show floor, there were many, many others. But the two I celebrate the most, because they are happening simultaneously, are continued innovation paired with practical developments that overcome the barriers that stand on our way to the goal of using additive manufacturing for more production work. Now let's review some of those new developments, starting with printers in the non-metal space. For these non-metal printers, I'll cover 2 for composites, 3 for photopolymers, and 1 for 2-part thermosets. Starting with the new composite solution from Impossible Objects. It launched its new CBAM 25 at RAPID TCT, which is an extension of its solutions for composite-based additive manufacturing. Its offerings produce parts manufactured with layers of composite material and polymer in powder form. At the launch, the company stated that CBAM 25 is 15 times faster, not of its predecessor, not of other composite machines, but of all machines in its class. The 25 in the product name stands for 25 feet per minute. That's 25 feet per minute of composite material, 18 inches wide, passing through the machine. That translates to roughly 1 vertical inch in 26 minutes, leading the company to claim that CBAM 25 is the world's fastest 3D printer. How does it achieve that, you might ask? Well, it's using technology developed for high-speed 2D printing, and 2 key elements of that are its web fed. A roll of composite material feeds through the machine, and it's also using piezo jetting that's completed in a single pass. CBAM 25 is all about achieving production-oriented throughput, but it has other advantages such as no limit to packing density and room temperature printing, which removes the physics from the processing equation. They're targeting a commercial release in the first half of 2024, but if you're interested today, Impossible Objects is now selling parts. Another composite solution came from 3DXTech. It launched its new machine, Gearbox CF2, where the CF stands for carbon fiber. But now I was surprised because I walked in thinking this was going to be a more expensive solution. And in actuality, it's their more affordable solution when compared to its high-temperature machine, the Gearbox HT2. It's a 30% price reduction. Gearbox CF2 is a material extrusion or fused filament fabrication machine that runs carbon-filled and glass-filled nylon, as well as many of the company's engineering-grade materials. Fully open material-wise, so it can run 3DXTech materials or those from third parties. and it provides access to profiles and archival of those profiles once you've developed the parameter set. It has onboard storage for 8 kilograms of material in a desiccated chamber, and if in the future you want to run high temperature materials, this machine is field upgradable to become a Gearbox HT2. The company is now shipping with only a 2 to 3 week lead time. Now, on to photopolymer solutions. And I'll start with Nano Dimension, which is known for 3D printed electronics and 3D printed microparts. In the latter category, it announced Fabrica Giga 25VX and Giga 250VX. Both of these machines offer 5 micron layers. The difference between them is the XY resolution and build area. The Giga 25VX offers 8 micron resolution with a 12 by 19 millimeter build area, where the 250VX offers 2 micron resolution with a 6 by 9 millimeter build area. And like their big brother, the Terra line, which has an even larger build area and higher Z resolution, the Giga line uses a DLP light engine. Currently, the Giga printers are in beta testing. Nexus 3D rolled out its new Zip Pro at RAPID TCT, and like its predecessors, it uses an LCD panel with LED light engine, and it also uses the company's LSPC, or Lubricant Sublayer Photo Curing process. Zip Pro is a continuation of Nexus 3D's theme of industrial printing in a desktop package. And for this printer, it claims the highest throughput and lowest operational cost in its class, with accuracy, with precision, and with surface quality. Zip Pro has a 19.5 liter build volume, so measurement-wise, that's 292 by 163 by 410 millimeters. And it can print up to 240 millimeters per hour, which means the entire build volume can be completed in under 2 hours when using the thickest layers, 200 microns, which the company states is the same output from 4 of the next fastest industrial 3D printers on the market. Sacrificing a bit of the speed, Zip Pro can print with layers as thin as 25 micron, and it offers a 7K light engine that delivers 46 micron in XY resolution, down to 23 micron subpixel resolution using some anti-aliasing technology. Nexus 3D is now shipping the Zip Pro. A direct competitor to Zip Pro may be Axtra 3D's new Lumia X1, which it states delivers speed with surface finishes that match injection molding surface quality. It achieves this via a hybrid AM approach. For the bulk of the part, it uses DLP. That's then combined with stereolithography to smooth out all the aliased bounding surfaces. And this process is called HPS, which stands for Hybrid Photosynthesis. Axtra 3D states that this offers the best of each process without the inherent trade-offs such as aliasing defects and isotropism or tiny build volumes. The Lumia X1 combines HPS with the company's TrueLayer technology, which has no limitations to the cross-sectional area being printed. So you can do large, bulky surfaces on this printer. And it has the ability to print highly viscous resins. While it claims print speeds equivalent to other 4K DLP printers, it does not state time per inch, so that'll be up to you to quantify. Build volume is 17.3 liters, which equates to 250 by 140 by 495 millimeters. And it prints in layer thicknesses ranging from 25 to 200 micron. Now, surprises abounded on the RAPID TCT show floor. For me, one of them was PPG. I think of this company for coatings. It has a massive reach in that area, so I was just going to skip right by their booth. But a friend told me they had a 3D printer, and that printer uses the company's Ambient Reactive Extrusion Process, or ARE. This uses material extrusion to deposit 2-part thermoset materials. So, they load in component A and component B of the resin system. Those are then blended at the point of extrusion. This opens the door to most materials with 2-part thermoset chemistries, ranging from tough and rigid to soft and flexible. And PPG noted that it has aerospace certified materials available. Right now, PPG has a strong focus on gaskets and related sealing applications. ARE can do large parts measured in feet in terms of length and width, but height is a bit limited, or very much limited, due to slumping, because it takes time for the 2-part resin to polymerize and solidify. So I was told that the ideal height is up to 2 inches. But please note, PPG is selling parts, not machines. Metal additive manufacturing was well represented on the show floor, and have highlights on 6 solutions, 1 for binder jetting, 1 for laser powder bed fusion, and 4 for directed energy deposition. We got a first look at Markforge's new PX100. This is a metal AM solution based on a binder jetting process. Now, the PX100 isn't entirely new. It's partly a rebranding of Digital Metal's DMP Pro, which was introduced at RAPID TCT 2022. As you may know, Markforge acquired Digital Metal last year. But there's more to the story, more than just rebranding. PX100 offers twice the print speed of the DMP Pro. It does this with single pass jetting of binder passing through 70,000 nozzles. With the increased speed, higher throughput, and lower cost per part, Markforge believes it has what is needed to really break into production. And speaking of production, PX100 retains the core of the DMP Pro that drives quality, repeatability, and reliability in a 24/7 operation. Items such as granite platform, linear motors, and air bearings. In the LPBF, laser powder bed fusion category, DMG Mori unveiled its Lasertech 30 SLM US. US is its designation for the machine being designed and manufactured in the United States. Lasertech 30 SLM US incorporates new laser technology called adaptive beam control, which provides dynamic changes to laser power and beam profile, profiles that range from an 80 micron spot to a 240 micron annular ring. Breaking the trend of adding more and more lasers to LPBF machines, this one is outfitted with a single laser with 1.2 kilowatts of energy. Another feature is contactless recoating. Now, when combined with optimized beam control, this single laser system can outperform DMG Mori's 2 laser systems for most print jobs. The bottom line, the company states that this printer offers the best cost-to-productivity ratio, which is total operating cost divided by the output volume. The Lasertech 30 SLM US has a build volume of 300 by 300 by 300 millimeters, and deliveries will begin in December of 2023. Next, I'm going to cover 2 containerized solutions in the directed energy deposition, or DED category. Addatech expanded its AMRC-P line with the Performance, name of the machine. AMRC stands for Additive Manufacturing Robotic Cell, and P denotes portable. This is a new, taller option that's also rated for reactive materials. Now, the cell itself measures roughly 3 meters tall, with a width and depth of about 2.7 by 2.3 meters, and it can accommodate parts up to 1.8 meters. Performance AMRC-P has a 6 kilowatt laser mounted on an industrial robot, coupled with closed-loop controls. I believe, but did not confirm, that this is both wire and powder-fed. This portable cell is sealed such that it can be filled with inert gas to make parts from reactive materials like titanium. And Addatech states that the deposition rate for titanium is up to 4 kilograms per hour. Now, announced in November of 2022, Speed 3D showed off its new X-Speed. This is also a containerized solution, but with a military focus. Beyond portability, there isn't a lot in common with Addatech's solution because Speed 3D uses cold spray, which they call supersonic deposition technology. The X-Speed is transportable as a standard shipping container with the printer and all auxiliary equipment in one box, requiring only a connection to electrical power to be operational. With deposition rates up to 100 grams per minute, the company claims that this solution is 1,000 times faster than any other metal AM process. With it, you can print in over 12 alloys, including copper, stainless steel, titanium, high-strength aluminum, and nickel-based carbides. And parts can be up to 1 meter diameter by 0.7 meters tall, weighing up to 40 kilograms. Now, something to note, when printing with reactive materials, inert gases are not required. That's because this process essentially is a solid-state approach. The powder goes from solid to solid in microseconds. Now, I'm going to continue with DED, covering 2 non-containerized solutions from Mitsubishi and Nikon. Announced in September 2022, Mitsubishi showed off its AZ600. This is a wire-fed DED solution, and Mitsubishi proudly stated that it makes everything in the machine down to the resonators, borrowing heavily from its expertise in its EDM and laser cutter product. The AZ600 offers lasers with either 2 or 4 kilowatts of energy, 5-axis motion, and a build volume of 500 by 500 by 500 millimeters. It also has auto detection and compensation for each layer during the build process. Now, another surprise I stumbled on was at Nikon's booth with its Lasermeister 102A. Now, I went to learn about its integration of SLM products following the acquisition of that company, but discovered that it had its own DED solution for 2 years. Now, although it's 2 years old, RAPID plus TCT was its first appearance in North America. This DED solution is powder-fed and has 5-axis motion within the chamber, plus an inert processing environment for reactive materials. Lasermeister 102A is a compact unit measuring under a meter in width and depth and 1.75 meters tall. It's targeted primarily for research and education. I'm now shifting gears, moving into solutions that address the barriers to adoption for production applications that leverage automation, software, AI, and more. And I'm starting with HP and its 4 solution announcements at RAPID plus TCT. Attendees of the event were treated to the first North American showing of HP's new Jet Fusion 5420W and MetalJet 3100. These machines were accompanied by product launches for both Multi-Jet Fusion, the polymer line, and the MetalJet lines. For MJF, it was additional automation. Last year at RAPID, HP unveiled automated unpacking for 2023. They've extended the automation to include its powder handling automation solution, which takes the auto unpacking a step further in terms of automation. The powder output of unpacking is now automatically processed through the entire workflow and returned to the printer. The benefits are cost reduction, productivity improvement, and consistency in both quality and traceability. Now note that one of these units can handle up to 15 MJF systems. And there was the announcement of the automation accessory that auto ejects and inserts build units so that there's no babysitting needed to keep printers running 24/7. With MJF's typical 12-hour cycle time, this option is especially important for those without a night shift. This option is also automation ready for integration to other factory configurations like autonomous mobile robots. At RAPID plus TCT, the company displayed videos of use cases with Siemens in which an autonomous mobile robot is able to retrieve a completed build unit and bring it to different stations within the automated powder handling workflow. For MetalJet, we had announcements for HP's digital production suite. They revealed 2 components of the suite, 3D process development and digital sintering. 3D process development is for developing and fine-tuning your process recipes. It opens up all the process parameters to users and also provides guided experimentation for process development. Digital sintering simulates the post-sintering process and then pre-compensates geometry to counter the shrink, drag, and slumping that happens in the sintering furnace. Reportedly, it takes only minutes and can handle large files. Stratasys demonstrated its new paid version of GrabCAD Print, called GrabCAD Print Pro. It adds features to the base software to reduce cost, print times, and human resources by utilizing automated processes, templates, and cost estimations. The features that caught my attention were warp adaptive modeling. This takes scan data from a print and compensates the digital data to counteract the defects in the next print job. They also have stacking parts in FDM and per part estimations, both for time and material. So instead of having an estimation for an entire build, it breaks it all the way down to, in a mixed batch environment, down to the individual part. And they announced plugins for third-party applications, highlighting Caster, a decision-making tool, should you or should you not 3D print, and AlphaStar, which offers simulation. GrabCAD Print Pro is now available for FDM and SAF, its powder bed fusion solution. And Stratasys stated that it has plans to add support for PolyJet, P3, which is programmable photopolymerization, and stereolithography. Aeon 3D is a company that offers high-temp fused filament fabrication machines for processing materials like PEEK and Ultem. At RAPID TCT, it offered a sneak preview of new software that's entering its beta testing phase. It's a simulation engine for material extrusion systems, specifically FFF, fused filament fabrication. It's based on new machine learning-driven thermal optimization that is purpose-built for, not adapted to, material extrusion. It offers fast, accurate predictions on heat flow behavior within parts during printing, with an advantage of doing the analysis and simulation using transient thermals throughout the build process. So this is not a layer-by-layer or whole part simulation approach. There are a few key benefits of this simulation. One, it simplifies parameter development for new materials, opening the door so that everyone can readily add materials to their portfolio. And two, it considers both geometry and material to provide insights for corrective action before you hit the go button on a print job. And three, it helps you identify inspection requirements, spending resources only where a problem could arise. The next two solutions are for the respective companies' laser powder bed fusion machines. Exact Metal announced its new software solution, Smart Layer. It partnered with Adaguru to build the foundation of Smart Layer for the company's line of metal printers. Smart Layer is an intelligent monitoring solution. It conducts a layer-by-layer analysis using computer vision algorithms and convolutional neural networks, providing anomaly detection in real time. Smart Layer identifies typical issues such as part swelling, streaks, hops, and spatter on the print bed and immediately notifies the operator upon issue detection to prevent print failures. In a similar vein, EOS is detecting problems, but it resolves them without user intervention, and it leverages the algorithm to reduce support structures. The product is called Smart Fusion, and it was announced at RAPID TCT. The software is designed to automatically adjust laser power in real time to minimize the need for support structures while reducing material use, post-processing requirements, and cost per part. It also intuitively detects potential build problems, auto-adjusts the laser power, and eliminates wasted time and resources associated with a trial and error approach. So, how does it do it? Well, it measures the amount of laser power absorbed by the powder bed with a high-resolution camera to monitor each layer's melt pool emissions. That data is then fed back to the laser so the power is adjusted to ensure homogeneous energy distribution across the whole build platform. This then helps to reduce stress in the parts, avoid metal overheating, and avoid movement in undesired directions. The next piece of news at RAPID TCT is in the MES and workflow software category. It's the announcement of AMFG powered by Dendrite. AMFG, the company, is leveraging Dendrite's recently released additive CAM capabilities, which provide for multi-vendor metal AM build preparation so that you can use one tool rather than bouncing between vendor-specific software, and also gain some advanced tools that allow, as Dendrite says, you to control the laser. What AMFG is doing with additive CAM is all about automation to address bottlenecks to autonomous manufacturing workflows. Bottlenecks created by the lack of standardization on file formats, build parameters, and protocols amongst the laser powder bed fusion printer manufacturers. This can be a big issue when machines from multiple vendors are involved or parts from different customers are mixed in one build. So AMFG, powered by Dendrite, incorporates the latter's additive CAM into the MES workflow with data automation down to the toolpath level. This combined solution enables laser powder bed fusion users to deploy automated ordering, automated collating, and dynamically processed part production services. AMFG, powered by Dendrite, will be available in the third quarter of 2023. AMFlow has been addressing another bottleneck in the additive manufacturing workflow, bottlenecks with high volume and or high mix outputs, and that's the labor needed to identify parts and where they are in the process workflow. Now, what's not new is the company's backbone of automation. It has, for a number of years, had a solution where you dump in a mixed batch of parts, and its vision system identifies the parts, pulling from MES or similar data sets, and then conveys the parts to the next step in the workflow, all the way out to bagging them for shipping. At RAPID TCT, it showed off Quality, which is the name for the new tool and its process flow. Quality ties into the workflow solution for inline dimensional inspection. By the way, it's both from the top and bottom of the parts. It receives pass-fail data from the vision step and then sorts based on a pass-fail status. It also generates detailed inspection reports for documentation. We need digital data to feed additive manufacturing systems, and we're wise to leverage the possibilities presented with design for additive manufacturing. In that vein, I have two new offerings for you. The company formerly known as N-Topology, now rebranded as N-Top, has rolled out its new N-Top 4 software. This is a major release with 4 new feature buckets. The first is field optimization. Essentially, it offers lattice design on steroids. The optimization of every point in space. Both the lattice and the cell are optimized. For example, lattice wall thicknesses can vary throughout a cell or throughout a part. The promise is a tool that decreases R&D and trial and error time to achieve the perfect lattice-based optimization. The second is implicit interop, which bypasses mesh creation, so you can have direct from the optimization datasets for much smaller sizes. Currently, this capability works only with EOS print. The third item is the developer library, which provides the hooks for others to integrate N-Top capabilities into their software. And the fourth is automate, which is all about scripting, avoiding the user interface to make sweeping changes across all selected parts. General Lattice is the company behind the lattice design for the Wilson Airless basketball, which was seen everywhere at RAPID TCT. It launched Frontier software for lattice creation. This tool is all about making good and appropriate lattice structures for your application without either serious know-how on tuning and refining or cycles of design, print, test, redesign. It streamlines the process for the average Joe by pulling from an extensive library of geometries, bulk materials, and machines. The company's focus is providing digital material solutions versus just lattices, where digital material is the combination of the lattice design and the material properties. I'll round out this RAPID TCT recap with quick mentions of 5 new materials that I discovered on the show floor. The first, Polyspectra. It added to its core COR line of photopolymers, which are cyclic olefin resins. The new material is called Core Bio, which you guess is for medical, dental, and bio applications using stereolithography and DLP printers. It combines toughness with heat resistance. On that latter item, it offers the example of being steam autoclavable. Also, it's non-leaching, has low moisture absorption, and low cytotoxicity. Jabal announced PLA 3110P, which is bringing an entirely new class of PLA to the market. This is based on NatureWorks Ingeo PLA-based powder. Powder for powder bed fusion, not filament for fused filament fabrication, making it the first ever PLA optimized for PBF. The advantages are 89% smaller carbon footprint than PA12 for powder bed fusion and lower cost, all because this is a bio-based material. And Formlabs announced its flame retardant resin for its SLA printers. It's UL94V0 rated. The product name, simply flame retardant resin. Essentium's material announcement went the opposite direction. It's a polycarbonate for low temperature applications. It can withstand minus 60 degrees C temperatures without cracking. They're targeting outdoor use applications like drones and electrical housings. It's not limited for use in its HSC systems. It can be used by any open source FFF 3D printing machine. And last, Uniformity Labs. It announced the availability of Unifuse IN625 nickel alloy and optimized parameters for laser powder bed fusion printing of that material at 60 micron layer thicknesses. Now note that it can use other laser powers and other scan parameter set and different layer thicknesses. But with this combination, the company claims that it's achieving 2.1 times faster exposure time and comparable or superior mechanical properties when compared to a competitor's 40 micron layer thickness outputs. That was just the tip of the iceberg for new solutions revealed and shown at RAPID TCT 2023. I hope this recap aids you a bit in your company's quest to take additive manufacturing to the next level. To stay on top of things, I hope you'll plan on attending RAPID TCT 2024. And remember, plan on bringing a colleague or two to have any chance of seeing it all.